These are the pre-calculus frequently asked questions for section 3.1, day 1. I'm going to start with number 10. And 10 says we are to compute the exact value of the function for the given x value without using a calculator. So we have f of x equals 8 times 4 to the x, but our x is supposed to be a -3/2. Now powers, exponents, only go to the closest thing to their left, which means it's that 4 that we have to raise to that -3/2 power, but a half power is going to be a square root. So we need to think of this as 4 to the 1/2 raised to the -3 power, so that we can go ahead and say, all right, this is 8 times, well, 4 to the 1/2, that's the square root of 4 to the -3 power, and that will be f of x equals 8 times 2 to the -3. Well, then f of x is going to equal 8 over 2 to the 3rd, because whenever we have a negative power, that's for a reciprocal, and that will be 8 over 8. So the answer is 1 for number 10. So that one is just some serious manipulation of our powers here. So remembering all of those power rules to get through there. Number 11. In exercises 11 and 12, determine a formula for the exponential function whose values are given in table 3.6. Remember, this is y equals a times b to the x. And how we find a is that it is always the initial value and it's always the y-intercept. That's going to be this value right here. So for f of x in number 11, we have an a value of 3/2. B is what they're multiplying by each time to get the next term. So I see that they're going from 6 to 3, from 3 to 3/2, from 3/2 to 3/4, which we think of as dividing by 2, but that would mean they're multiplying by 1/2 each time. So that is our B value, and this will be y. Actually, we want f of x on this little bugger. So f of x equals a 3/2, and then we have our b value of 1/2 to the x power. So that's number 11. That one is just like an example that we did in class. Number 13 says in exercises 13 and 14, determine a formula for the exponential function whose graph is shown in the figure. And what you have to pay attention to in number 13 is that this is not going by ones. We jump from 0 to 2. So this was 0, 3, and then it was 1, something, and then 2, 6. So we think, well, how did they get that? I mean, we already know what a is. A is 3, because that's our initial value of 3. But what did they do to get the 6? Well, they multiplied by something. We don't know what it was, and they got the middle number of the y value, and then they multiplied by it again to get the 6. So they took 3 times x to get the 6. That's 3x squared equals 6. We divide both sides by 3. X squared equals 2. Take the square root of both sides. And because everything is positive here, we know that they're going to be multiplying by a positive square root of 2. So that really is our b value. And our a value was 3. So for number 13, we have f of x equals a value of 3, square root of 2 to the x. But when we're working with these exponential functions, what we want to do is not have radicals in there. So we need to think of the square root of 2 as 2 to the 1/2 power. So this will be f of x equals 3 times 2 to the 1/2 to the x, which is 3 times 2. And then power to a power, you multiply. So 1/2 times x would be x over 2, or 1/2 x. It really doesn't matter as long as we can show that we understand that that power to a power is to multiply. And let me quick check here how the book gives those answers. They did put x over 2 versus 1/2 x, but it doesn't make any difference. Both of those will give you the same product. All right, in the end. Number 14, we have g of x, and we see that we have 0, 2, and then we have 1 and 2 over e. Well, we should be happy that it's gone by an interval of 1, but not so happy that they're introducing all of this e stuff. So from left to right, it has moved from 2 to 2 over e. So they took 2 times something and got 2 over e. So what I want to know is, what was that something? What did they multiply by? To do this problem, easiest to just make this a fraction and cross multiply. 2ex equals 2, and then we go ahead and divide both sides by 2. So ex equals 1, and then to get x by itself, we would divide by e, and x equals 1 over e. So that is our b value, 1 over e, with some algebraic manipulation here. And this, of course, the 2 is our a value, because it's always the initial value. It is the y-intercept, so 0, a. And for 14, they called it g of x, and that equals a, which is 2, times 1 over e to the x. So that's our job, figuring out what a is and then what b is, what they multiply by, so that we know what base we're using for our exponents there. Now, again, because we're talking about exponential functions, we could see this written as e to a power instead of that fraction. So this could be 1 over e is e to the negative 1. So this could be g of x equals 2 times e to the negative x. You never know in a multiple choice problem on a calc exam whether or not you'll see it one way or another. But either one of those answers would be correct. Number 21 says, describe how to transform the graph of f into the graph of g. Sketch the graphs by hand and support your answer with a grapher. So for number 21, we want to think about what this negative 2x is doing up here. And the first thing we see is that's going to be a reflection, and because it's with the x, it's a reflection over the y-axis. And then we have that 2, and because it's with the x, we remember, wait a minute, that's always opposite of what I see, what I think about when I look at it. So that is a horizontal shrink factor of 2. So away we go. First thing we want to do is get those points that we've talked about in class as kind of memorized points. Your 0, 1, and your 1, 2.718. And your 3, 7.389. About like so. So that's our parent function. Notice it's dashed. That's not our final product. And we have two things to do here. We have to reflect it over the y-axis. And what that does is it makes all the x's negative. So instead of positive 1 and e, we would go with negative 1 and 2.718. And instead of positive 2, 7.389, we go with negative. And again, not our final graph. But we can see how that has definitely reversed our end behavior here. And then last but not least, we need a horizontal shrink factor of 2. That means whatever we had for those x values, we have to cut that in half. So instead of a negative 1, 2.718, we will have a negative 1/2, 2.718. And instead of negative 2, 7.389, it will be negative 1, 7.389. And then we think about what's going to happen with our 0, 1. Well, if you multiply 0 by 1/2, or think of it as dividing by 2, you're still going to end up with 0. So it's still going to go through that point at 0, 1 as initial value there. And there is our graph. And like it says, you can certainly check that result with your graphing calculator, but we have everything that we need there. Then, number 33, state whether the function is an exponential growth function or exponential decay function and describe its end behavior using limits. So with 33, they're putting that decimal there to kind of mess with us. We have 0.5 to the x, which is 1/2. It's 5/10. So 1/2 to the x, this is a fraction between 0 and 1, so this is exponential decay. And that means it's going to look like this. Now, we don't have any transformations taking place here, so basically it is its own parent function. So when we think of the limit behavior, we really just need this sketch. And to remember that our asymptote is the x-axis, which is the line y equals 0. So our limit as x approaches negative infinity of f of x, and our limit as x approaches infinity of f of x, means that we can just use that sketch to kind of make our way through. And generally, we wouldn't even need a sketch. You could think through this in your head about what's going on, because this graph, as we go to the left, is going up forever. So that will be infinity. And as we go to the right forever, this is approaching our asymptote at 0. And so that's how we would describe the end behavior on number 33. Now, for 36, I need to pull up the graphing calculator, so I'm going to pause this. 36, we are to solve the inequality graphically, and they have 6 to the negative x. When is that greater than 8 to the negative x? And I'm not sure if the calculator will take it that way or not. I've tried it on my smartboard one, and it's not taking it, but I wouldn't even think of it that way anyway. What we would want to do is simplify this by remembering that negatives are reciprocals. So really what we want to find is when is 1/6 to the x greater than 1/8 to the x. And this problem kind of drives me nuts because I want to show you the logarithms for this, but they want us to do this with the GC, with the graphing calculator. So we go into y equals, and we get those two little monsters in there, and we hit zoom 6 in the hopes of having this be incredibly clear. And the first graph that we're going to see is the 1/6 to the x, and that's in the blue. And then the next graph that we see is going to be the 1/8 to the x, and that will be in the red. And really troublesome view at this point, because we're not seeing what it is that we really want to see, which is when does the 1/6, when is that greater than the 1/8 to the x? So I'm going to change the window a little bit, and what we really need to see is what's going on at the crossing of these two, which is going to be very small numbers. So our x's, I maybe would try -2 to 2 to try to see that intersection. And then my y's, I'm really just interested in from -1 to 1, what exactly is going on there, and by a scale of 1. So, well, we could go by 0.1 if you want to, but the scale doesn't really matter. We'll hit graph. So we want to see that blue. And then the red. And we can see right at the top up there that it is at that 0, 1 where those two are meeting. And you might want to change your window just a little bit more so you can see that y max. I'll go 1.5. There's the blue. There's the red, and we can see that the blue is above the red once you pass the y-axis. And the y-axis is, of course, x equals 0. Now, you might want to zoom box this in if you're not sure, because it's still a pretty good close call here for these two. So maybe we box this in a little bit and just focus on the intersection. So I'll hit enter. And what we're doing is marking that upper left-hand corner as the upper left-hand corner of a box. And we can see, we could tweak our window. We don't necessarily need all of the x values that we have there in the negatives. But zoom box is always good to get a look at exactly what it is that you want to see. So now as I go to the right, you can see that this is extending. And I'm going to stop there and hit enter and let the calculator zoom in on what's taking place. So there's our 1/6. Again, we want to see when is the blue above the red. And there it comes. And now with that zoom box, a little bit better view, yes, blue is above the red when we have an x that's greater than 0. So, back to the smartboard here. You would put when x is greater than 0. Number 39 says in exercises 39 and 40, use the properties of exponents to prove that two of the given three exponential functions are identical. Support that graphically. I don't know that I'm going to show you the graphical part of this, but the first thing you should be suspicious of is, why did they put a 9 there? The other bases are 3's. Well, that's what they want us to remember. So y sub 3, we can write 9 as 3 squared to the x plus 2 power. And then we need to remember that when you raise a power to power, you multiply. So it will be 3 to the 2x plus 4. And now we see exactly what they were trying to hide from us. It is A and C that are exactly the same. And you could certainly punch those two into your calculator to make sure, just kind of double check. That's what we're using our calculator for more and more now anyway, is just to double check and make sure that those are going to be the same. So y sub 1 is the same as y sub 3. There we go.